Hi, everyone. Thanks so much for having me today. What I wanted to talk about was, we heard Mackenzie talk a bit about all of the different things, types of machine learning and AI services that are out there. And you're going to hear a little bit later from venture capital investors on how they're thinking about companies. And I wanted to kind of bridge that in the center and talk about how to think about machine learning from a strategic perspective as it applies to your company. So this is a rendering of what I might look like. So just to give you a brief background, my name's Matt Hartman. I am at Betaworks. And at Betaworks, we do a couple of things which I'll talk about. But we build companies, and we make seed investments in outside companies. We do both. So my background was that I had built a technology platform for a big real estate developer, which we ended up selling to CBRE. Then I joined a company called Hot Potato, which was a consumer social media company. We ended up selling that to Facebook. And then I started a company that was sort of at the intersection of those, which was a real estate tech product, which I licensed to Apartments.com. Betaworks originally had been an investor in Hot Potato, which is how I ended up joining Betaworks. And for the last 4 years, I've been investing in mainly the consumer internet, but also kind of, I'll talk a little bit about how we think about new interfaces and the way we communicate in new interfaces. So at Betaworks, I mentioned we do two things. We build and we invest. So these are a handful of companies we've built on the far side here, and then on the closer side here is the companies we've invested in. And the thesis early on was that the way we communicate in social and then in mobile changes in these new interfaces. So once we get to mobile, we sort of started thinking about what's a post, how do we communicate in kind of a post-home screen world? And this is where machine learning is becoming even more important. And so the categories that we think about generally are visual, so augmented reality and virtual reality, conversational software, so messaging, whether it's communicating inside of a text message or inside Slack or Facebook Messenger, and then verbal computing and audio. So that's anything from podcasts to Amazon Alexa skills. The machine learning component of this is underneath augmented reality and virtual reality is computer vision. And underneath conversational messaging and verbal computing and audio is natural language processing and speech generation. And so these are, when I'm thinking about machine learning in general, I'm thinking about it as it applies to specific startup use cases. So I would talk a bit about how VCs think about machine learning just from a strategic perspective from the startup. How, as a startup, you can think about machine learning, what you can outsource entirely, what makes sense to keep in-house, and then what maybe makes sense to not even pay attention to. And then, if we have time, I'll touch on the future of some interesting sort of frontier applications of machine learning that are in a category that we're calling synthetic media, which is both sort of interesting and frightening. So first, how VCs think about machine learning. So this is at least how one VC thinks about machine learning. And so for context here, for the most part, in the last 4 years, I'm working on the investment side of Betaworks. So we have a venture capital fund, and so I spend most of my time on the venture capital side. So this is sort of the framework that I use. It's not the prettiest, but you have data, you have untrained algorithms, and when you combine those two things, you end up with a trained algorithm. And so the way that I think about this is, on the data side, the startup, the company should ask themselves, is the data proprietary or is it not? So an example of that might be if you're Google and you have a bunch of search data and you want to start to do predictive search, you have a big head start on somebody who doesn't have that search data. If you're a startup and you are trying to identify X-rays, figuring out if there are bones that are broken in a particular X-ray, you don't have a particular disadvantage against Google because they don't necessarily have that labeled data set. When we move on to untrained algorithms, one question that we ask is it open source? And Mackenzie hit on some of this, and I'll talk about this in more detail. But is the untrained algorithm something that you own? Is it something that's proprietary from like a technology perspective? Or is it really totally open source and anyone can get it? And the value is that you're adding your own proprietary data, and then that comes together with the trained algorithm. And the point I want to make on the trained algorithm is two things. So the first is who owns it. So in some cases, you're going to be using a SaaS product and you will be training their product and you're just going to get the output. In other cases, you're going to be, you own the trained algorithm and it's really important. And so you don't want to give that up. And so that's sort of how I think about ownership. The second part of that is how much better does it get as the amount of data improves it? I almost think like, is there an asymptote that is it 10 million data points or is it like 50? If you need 50 data points to train your algorithm, then someone else can come get the 50, say, a different 50 data points and catch up to you. Another thing to compare that trained algorithm to is what about other mechanisms for solving the problem? So if you have a really, really good way to do face detection, it has to not only be better than, it has to be better than all of the other ways to do face detection. If it's only 1% better, does that matter? And so like, can a consumer, in the case of a consumer product or an enterprise customer, can they tell the difference using your trained algorithm versus whatever the status quo is? So that's kind of the framework we'll think about how to apply it in your company. So the one way to think about the different types of machine learning is there's true computer science algorithms. So 10 years ago, neural network, deep neural networks are sort of a buzzword now. 10 years ago, those were in colleges being studied, and that was a breakthrough technology. When it then went to the point where it was, so that was a computer science algorithm, an idea. Then it went to the point where it's a technology. Some people started to implement it. Then people started to say, okay, let's put it on GitHub, let's make some open source versions of this. And then it moved to the point, the third category, which is it's a SaaS APIs. So now there are people who say we are deep learning as a service for facial recognition, for topic modeling, for a bunch of different categories. And the natural state of things is that as these things come out of universities, they take a long time and they eventually get to the point where they're SaaS APIs. And it's just important to keep in mind that when you think about yourselves as a machine learning company or as a company that leverages machine learning, knowing what kind of machine learning, which category the stuff you're working on falls in is important, particularly when you start to pitch yourself to potential customers and potential investors. Just as a point, like if you don't have a PhD computer scientist, you're probably not in the computer science algorithms category, right? Like if I can recode it in 15 minutes, and I'm not a particularly good developer anymore, or maybe ever, then that means that other people can also do the same thing. So it's sort of a competitive analysis. So second way to think about this, and I'm going kind of quickly because I want to make sure we have time to have questions. Second way to think about this is what's your competitive moat? So I'm kind of dividing this into two categories, which is machine learning matters and machine learning doesn't matter as a core competency. So you have brand and sales kinds of companies. So I'll give you an example. Warby Parker is a brand and has amazing user acquisition. If they use machine learning, that's fine. But if one way to think about this, I would argue that it's not core. You kind of use whatever's best. If a competitor got their trained algorithm about like how to fit glasses to your face, I would argue that is not the key differentiator for that company. And so the fact that got out, they might even say, you know what, we don't care about that, because the thing that people are coming for is for their glasses design for the brand. The other kind of company, which I would argue has some real value, particularly on the data side, is a vertical or data company. So where are the cases where trained algorithms are really valuable and where more data equals better results? And then there's not a I used this word earlier, not a near-term asymptote, meaning there's not it's not easy for somebody else to go grab that similar data and create the same output. And so in that case, if you think about your machine learning algorithm leaves your company, that's actually really bad, right? And so a quick example of this is a company like Clarify, which is going in, collecting data. They have a bunch of trained models to do things like tell you what's in an image. And if that were totally open source, you would just stop paying for Clarify. And so that's a way to think about that. So I thought the last thing I would do is walk through just 3 examples of companies that use machine learning in different ways and whether or not it's key. So Anchor is the first example. So this is an audio social network. Right now it's the biggest audio social network. They have a brand. The consumers go directly into the app. They have a network, the user-generated content, which originates inside of Anchor. And I would argue machine learning is a feature here. They have a feature on there that actually has helped them grow a lot, where you can record your audio and then it renders it as a video with the audio in the background and then it shows the words. So they can use a SaaS API to process that. They can use, if they want to have particular intent detection because they want to let you use it hands-free, they could use something like Lex. It's not a key core competency. It's okay to outsource that, right? So my verdict is you don't need custom trained machine learning. You can use an outside API. A second example is a company that we built at Betaworks called Giffy. They have a super strong brand. And I would actually argue here that one of the most valuable things they have, is in addition to their brand, is the business development relationships they put together with different messaging companies. So chances are, if you're using Giffy, you're inside of a messenger app, and it just pulled in automatically, whether it's iMessage, Facebook, Twitter, inside of Slack. And so the problem that they might want to solve is making sure that when you do a search, you're finding the GIF that is the most relevant. So this is, in a way, a computer vision problem. So they can't necessarily they could pull up a sort of out-of-the-box face detection, that's fine, but people aren't really searching for the word face. But they might be searching, I'll give you an example, for the word touchdown. And if you think about what a touchdown is, you actually have to, there's not, I don't think, a company that has created a model for like what a video of a touchdown looks like. But you can think, okay, well, there's a football in there, there's a helmet, there's a field, there's probably a goalpost, maybe. There's a lot of, it's sort of a fuzzy logic problem. And so that's the kind of thing that you could imagine labeling a bunch of GIFs and putting them through a deep learning network, or picking your sort of algorithm of choice and training that. And the output is important, but I would argue that the output isn't absolutely critical. If someone else got that, it would be okay, because the reality is, if there was another search engine for animated GIFs and they happen to be able to identify that just as well, the key differentiators for Giffy are brand and also the fact that they are in front of you always. They sort of pierce the veil of all the different social networks that you're in so that you can use it. So here my verdict is custom trained ML is important, and it'll make the product better, but it doesn't necessarily need to be their core competency. My final example is a company called Aroo. This is a new startup and the thing that they do here, I'll just explain what this is for a second, because this is one that people might not know. They dynamically insert images into video. So this is I took a screenshot of a video here, but this is a I'm stepping out of the box, so you won't be able to see me, but this is a ping pong table. This is dynamically inserted. So this wasn't there originally. So a couple things here. One is it matches the skew of the ping pong table, so it's angled. It matches that. It found that open space. And you can see here the ping pong ball is actually on top of it. So the image doesn't obstruct it knows it's in the background. So it matches the blur and all that. So the reason I bring this company up is because the problem they are solving, the computer science problem they are solving, is actually a difficult one. So in this case, their technology injects new content into pre-recorded video. So they do have to have relationships with customers, with brands, with video players. But they use the machine learning they use computer vision to determine the angle, blur, and foreground. And that's actually pretty critical. If you pictured them going to pitch a new company on this and somebody had that same technology, the pitch would be about the same. So my verdict here is that proprietary is critical. You want to store those, you want to have ownership of those, of the technology that you're building here. And so and again, as I said when I sort of started out, in this case, it's 2 computer science masters and a computer science PhD who built the technology for this stuff. And that sort of, as an investor, makes it more believable that this is actually a hard problem. They came right out of university trying to solve this specific set of problems. So I'm going to give you, I'm going to do this last set of things, but if you can think of questions, I'll go to questions in a minute. So here's some food for thought is on synthetic media. So I said 10 years ago we had deep neural networks just starting to begin, and now those are all the way to the point where those are SaaS products now. You can sort of plug right into AWS and use those. So what are the things that are just now going from technology to kind of proprietary? And this is just sort of a category I find interesting. One is called Lyrebird. And by the way, neither of these things are investments. I just think they're cool. So Lyrebird, I don't know if I'm going to be able to play this for you or not. But actually, I pulled it up on my phone. So we'll see if I can. So this is a synthesized voice. So you open it up and you record your own voice. And you record it. They say it takes a minute. I found it took about 5 minutes. You record a bunch of sentences, and then it reads this out loud for you. So let's see if you can hear my voice now that you've heard me talk. It doesn't speak as fast as I talk. Oh, maybe.
Hi, everyone. Thanks so much for having me. My name is Matt Hartman, and today I'm going to talk about the emerging world of artificial intelligence and machine learning.
So it's not great. It's clearly not me, but it's kind of scary. You could imagine what this means for sort of social engineering. I can't actually think of very many good, positive use cases, but imagine, that you get a phone call from somebody who sounds exactly like your best friend, and they're like, "Oh, tell me all your secrets." Right? You're like, "Sure." It's my generic example. But it's super interesting because one of the problems on the voice side, if you think about where we are right now with voice interfaces, is that it's tough to listen to mechanical voices. They're really good for utilities, telling you things like the weather. I think I might be an outlier because I listen to written articles read by Siri at 2x speed. But normal people, I think, don't think that is that entertaining. And you can imagine like having a celebrity read that to you, or having somebody with a really calming voice read that to you, or an excited voice if it was an excited article. The second scary thing that I'll just freak you guys all out with is at Washington University, they created synthesized video. So there is actually audio for this, but I didn't want to have to click all the way into it on YouTube. These are synthesized Barack Obama faces and smiles and mouth movements. And they go along with audio that he actually recorded. So they watched the video of it, they grabbed the audio, and they generated a new version of Obama doing this. So combine those two things, synthetic voice and synthetic images, and I think we're in a totally different category for fake news. What truth is going to become super hard to tell. Right now, it's kind of hard to tell. Oh my. So I'm going to leave it there for a moment. Do you guys have questions? Are there questions? So I'll leave it there. I'm Matt Hartman. I have a newsletter on voice interfaces specifically called hearingvoices.xyz, where I share a bunch of Alexa skills, a bunch of types of products for developers, things like the AWS layers that Mackenzie was talking about earlier, as they come out to help developers understand where the new speech APIs are going, and then just industry news in general. Yep.
In previous slide, you mentioned data and untrained algorithm. I do respect, I know you are very intelligent machine learner, but I would like to suggest that should be corrected to the data and raw data, because algorithm defined as setup steps or instruction results in final conclusion, or results in some results.
So I think about the results as...
For instance, I would like to say raw data is like number, integer, etc. But when you train your data, it's not going to be raw data and can be used in algorithm to create a model and finally get a solution. Thank you.
Yeah, so I totally agree. Should I grab this? I totally agree that, so there's data, there's sort of absolute raw data, and there's like tagged data. And then there's the output of that data. When I'm talking about, the reason I put data into one category is that from a just strategic perspective, if you're trying to get to the point where you have a better result, and the better result comes from the trained model, the question is how hard is it for someone else to replicate your result? Kind of doesn't matter how, right? It could be like a one-line heuristic. It's just like if this, then that, and then you get your output. But to me, the source of the data and how easy it is for other people to access the data is one of the inputs that helps train the algorithm. Is that so? I think I agree with you.
Adding that to the point, we cannot say raw algorithm, but we can say train data, testing data, validation data, and training sample data. But we cannot say untrained algorithm. Thank you.
Interesting. Okay. I think we might agree to disagree that like if I take an open source neural network that I haven't trained and I haven't done anything, that's the algorithm. But I think I hear what you're saying, that it's nothing until there's things flowing through it and it's be able to generate something. So that's a fair point. Another question.
So outside of what we think of as the major voice, Google Assistant, Siri, Alexa, is anyone doing a really good job with voice UI in an application that you've seen so far?
Yes, there's a bunch of people who are doing interesting human-computer interaction inside of voice user interfaces. So I think when you say outside of Alexa, I think about products built on top of Alexa. So I think there's a bunch of good Alexa skills and a bunch of kind of mediocre Alexa skills, and then ones that you don't use at all. And one of the big things is whether there's kind of two parts to it. One is in voice, one of the problems is growth is hard, but also retention is really hard. There's no home screen to remind you to do a thing, so you have to find triggers. So for example, a flash briefing is a really good trigger because you wake up in the morning and you say, okay, I'm going to get the news. I think I was talking to somebody recently who's the developer of he put 2 trivia skills in the App Store. One is a trivia skill it's called Question of the Day, and the other one's just a trivia skill. And what he found was the retention was great on they're both very popular, but it was interesting to see the difference in retention when you just remind somebody to use the thing. So I almost include that as part of the human-computer interaction. In terms of products that are doing a good job with conversations back and forth, I think I use an email app called Astro, which has a bunch of features, but the one I use it for is that you can walk and talk to it, and it will read your email out loud. And I think they do a good job of saying, okay, what are the types of responses that you might want to give? So it's like next email, when it goes from subject, you can read the whole thing, you can archive it, you can actually respond to the email itself. And I think they've done a good job of creating a really straightforward user behavior there. But I think it's still early. I mean, yeah, I think it's still early.
So I had a question. It's not a technical question.
What was it? Okay.
But when you were talking about Giffy and the barriers to entry, and it seemed that it was more of a first mover network advantage rather than anything else because they had those relationships. And is there a differentiator between what you see their moat is versus first mover advantage?
Not entirely. I do think that I agree that they were super early, and in a category that like wasn't a category. People weren't like, oh, who's going to build the first animated GIF search engine, right? And so I agree with you that they were early and executed very well. I am always conflicted on whether the first mover advantage is a thing, and to me my current state on it, and I'd be curious to hear what other people think about this, is that the slower ramping up time is, the more valuable a first mover advantage is, because if you get ahead, it will take other people a long time to move first. But we're in this stage right now where things can grow so quickly, including Giffy, that it's like, just because somebody moved first. I mean, look at like search engines, right? Google was the 14th search engine. It was in a way, very easy to spin this up because you could just tell people about it. I mean, telling people about it's hard, but if people find out about it, they can switch over to it. I think we're seeing that with social networks in some ways, where people are willing to switch over. It turns out now that they have their contact list and they can just press OK and it connects them to all their friends. So I guess there is probably a piece of first mover advantage. I just am always hesitant to assign that as a reason.
Our timing algorithm says we have time for one more question.
Okay. And someone have a microphone? Was it pre-selected or should I? Oh, okay.
This may be, this is a non-technical question and may be a good segue to the next segment. So looking at your slide for what is your moat, using that dichotomy, is that how VCs determine whether or not a particular startup is valuable or not? One of the ways, I should say.
Yeah, I was thinking about that because you don't always, it depends on what size company you're trying to build, whether how much a moat matters. So at the small scale, if you're starting a restaurant, there may be nothing, you're sort of creating a differentiated product and people can copy it and you're just trying to build a really good product. the thing to keep in mind, particularly with venture capital, is that the model is to invest in, out of the companies I showed you on that first slide, with like a lot of cool brand names, of the 100 companies we had invested in, 10 of them drive all the returns. So when I look at, I mean, and I'll tell you why this is important to the moat, right? Because 20% of them go to zero. The next 20% of them return 0 to 1x. So you put $1 in and you get $1 back. The top 10% return over 10x. So you put in $500,000 and you get 5 million. But actually, when you look even in that small segment, there are some that are 100x or 150x. And so the reason why that's important is that the big winners drive much, if not all, of the return. And if that's the case, then we always have to ask at the beginning the question of, okay, let's just assume this thing works. Will other people, how long will you have an advantage so that you can become that really big company? And that's what drives the question, what's the moat? Thank you guys so much, and I'll be around here if you guys have any other questions. My email, by the way, it's not on there, but I'm M@Betaworks, so please feel free to email me if you have any follow-up questions.